Hello everyone, this is Group22 and M1. We are going to talk about AI deployment in society. We have 4 cases that represent the typical areas of AI from research to social impact in different fields. First, there is IBM Western's attempt to commercialize healthcare. However, in real clinical environments, problems like poor data, dishonesty of the system, and weak management cause fail. This showed that strong technology doesn't always mean business or clinic success. Second, automated hiring systems sometimes reject people based on age. This caused serious discrimination and legal action, such as fines and required changes. It shows that companies are responsible for their algorithm and must ensure fair and careful design. Then, Tesla's autopilot has safety problems. Although popular, it didn't enough safe. This case shows the risk of releasing AI products too quickly without enough safety control. Finally, an AI system was trained on many 3D eye scans to predict retinal disease. It could tell which eyes might develop a several condition within 6 months, often performing as well as better than doctors. This case shows how AI helps preventive healthcare when supported by good data, clean goals, and expert teamwork. In summary, these 4 cases show a main conflict between what technology can do and what society needs. True success needs both. If either is missing, AI causes failure, harm, or legal trouble. The 4 cases demonstrate a common pattern in the reason for success and failure. The success or failure of an AI project depends not only on algorithm performance, but also on the balance of data quality, task matching, ethical governance, and human-machine collaboration. The success of Morpheus Google's retinal prediction system lies in high-quality clinical data, expert collaboration, and interpretable model design. IBM Western failed due to a disconnect between data and clinical reality, as well as active commercialization. iTutor Group's automated recruitment suffers from discrimination due to a lack of fair and compliance supervision. Tesla Autopilot, on the other hand, has caused accidents and regulatory oversight due to neglecting human-machine boundaries and safety measures. Overall, if technological capability lacks systematic governance of social, legal, and usage contexts, they will shift from innovation highlights to failure risks.
Let's talk about the main notice and gap across 4 cases, and review the common reason behind their success or failure. First is IBM Watson. It showed great skill in understanding language and finding answers, but when IBM tried to use it in healthcare, the project did not work well. The main problem was not the technology, but how it was used. The data was messy, and IBM promised more than it could deliver. iTutor Group's AI recruitment system was supposed to make hiring faster, but it automatically rejected older job seekers. The company later had to pay a fine for age discrimination. The failure here was not about weak algorithms, but about missing ethics and human chance. On the other hand, DeepMind's project with Morpheus Eye Hospital is a story of success. The AI could read eye scans and detect more than 50 deaths as well as top doctors. The key innovation was that the system helped doctors instead of replacing them. DeepMind also tested carefully with real hospitals before any real use. This careful design filled the gap that hurt Wilson and iTutor. For Tesla Autopilot, it is a very evidenced driver assist system, but it has also been linked to serious crashes. The problem is that some drivers trust it too much and stop paying attention. The technology is powerful, but the safety rules and user awareness have not kept up. Again, the main issue is not the AI itself, but how people and systems work with it. Across all 4 stories, one lesson is clear. AI works best when it supports humans. It stays responsibly and stays transparent. AI fails when excitement grows faster than control. So the real question is not how smart. So The real question is not how smart AI can be, but how responsibly we use it.
Building on those key issues, I will talk about the main limitations, biases, and risks we can see in these 4 AI cases. The first one, IBM Watson, was amazing on the game show, but it doesn't work as well in the real world. It's hard to apply to open and messy tasks, and it needs a lot of manual updates to stay accurate, which makes it costly to maintain. Because most of its data came from English and Western sources, it shows language and cultural bias. It's also designed for short factual answers, not deeper reasoning. Outside the show, people may overhype or misuse it, and if updates stop, it can give old or wrong answers, which hurts public trust. Let's move the second one, the iTutor. The iTutor system was built to speed up hiring, but it values speed more than fairness. It learns age and gender patterns from old data and starts to repeat them, turning human bias into automated bias. The risks include legal problems, damage to reputation, and less diversity in the people it selects, all of which reduce public trust. The second one, the more fair system performed even better than experts in one hospital, but it may drop in accuracy with new cameras or different patient groups. Its data is unbalanced, with too few samples from rare diseases, which leaves blind spots. And because it uses medical images, patient consent and privacy are major concerns at every step, from collection to reuse. The final one, Autopilot is a driver assist system for self-driving. It works well on common roads, but struggles with unusual cases, like poor lighting or rare obstacles. Sometimes drivers react too slowly because they trust the system too much. Its train also lacks diverse roads and weather, so the risks of accident and misuse are still high. Across all 4 cases, the pattern is similar: limited data, unclear human AI roles, and weak oversight. This leads to unfair results, safety problems, and legal risks that affect real people.
So here's the point. When an AI system makes a mistake, it doesn't stay inside the computer. It happens in real life, and people can get hurt. That's what makes AI very different from a normal tool. In good examples like Watson and DeepMind, AI didn't try to replace people. It just helps them do their work better. Doctors could find problems faster, and workers could search for information more easily. So here, AI works as a helper, not a replacement. But in Tesla and iTutor, it's the opposite. One small mistake, like a driving error or hearing bias, can grow in a big problem. A driving error may cause a crash. A bad hearing algorithm can quietly stop thousands of people from getting jobs. So, from a system view, AI's influence is never small. If it's designed checked well, it helps people. If not, it can make things worse very fast. That's why human checking is so important. It decides whether AI becomes a good tool or a social risk. The main idea from all 4 cases is simple. High accuracy doesn't always mean it's doing the right thing. An AI can look smart, but if not one correct, it can go in the wrong direction. In the 6-4 cases, people stay involved. For example, DeepMind works with doctors. When the system starts to go off track, real feedback helps fix it. That's what true alignment means: AI and people working together. But in the failed cases, there were no feedbacks. Tesla and iTutor didn't notice problem earlier, so the system just kept running wrong, and people had to pay the price later. So we shouldn't see AI as something we made once and forget. It needs constant care and updates. In short, alignment is not a one-time trick. It's something we keep doing. Thank you.